Ever wondered why antibiotics cure some illnesses but don't work on others, or why cold and flu treatments seem to differ? Today, we're solving this mystery by diving into the fascinating world of bacteria and viruses. And we're going to answer some questions like, can bacteria evolve to become viruses? What's the difference between bacterial and viral pneumonia? Can probiotics really boost immunity? And we're going to be dealing with all of that right after this. Welcome, everybody. This is the Life Enthusiast online radio and TV network, restoring vitality to you and the planet. I'm your host, Scott Paton, and joining us, as usual, is Life Enthusiast health coach, Martin Pytela. I almost said Life Enthusiast life coach. Hey, Martin,
I can coach you lifely or healthily.
There you go. Yes. So there's been a lot of discussion about viruses and bacteria and antibiotics, and I wanted to kind of dive into some of that stuff. And before we do, I want to remind everybody that after the show, we are going to be live on Telegram. And
there it is.
There it is. And here's the bigger one, which is t.me/life-and-co. And that's where we talk about what's really going on, what we really think, where we're no longer censored, where we're unleashed. And want to make sure you all tune in for that. So make sure you join us.
Yeah.
So with that, let's talk a little bit about bacteria and viruses.
All right. Well, so with bacteria, it's easy story. Bacteria are single-cell organisms that are capable of reproduction and have their own life. And they have been studied heavily back in the 1800s. And there is this thing called Koch, or Koch, if you want to have it in German, principles or postulates, as he put it. And Robert Koch actually established that there is a way to prove that something is an infectious bacteria. And these four postulates were: one, a sick person has it, a healthy person doesn't have it. Two, you can isolate it. And if you take the isolate and put it into a previously healthy person, that person will become sick. And if you, what's the other one? Oh yeah, and a sick person has it and a healthy person doesn't have it. So this, for example, works marvelously well for bacterial problems. Imagine something like gonococcus, which is the cause of gonorrhea. That's a bacterial transmission. Very identifiable and very recognizable. Another typical example would be tuberculosis. You have it or you don't have it. And you can actually, with tuberculosis, you can establish an immunity. Your immune system can figure out how to defend for it. I don't think there is an antidote for gonorrhea. Never heard of it. But interestingly, the invention of the 1930s, antibiotics, were capable of suppressing bacteria. And you could understand it this way. The way it was found, it was some bread was going moldy in a laboratory, and a bit of the bread or bit of the, I don't remember the story clearly enough now to tell you. I might just fool myself. But the story was this. When there was this particular fungus present, it was not moldy in a vicinity of that particular spot. And what they figured out from that was that the fungus was making an antidote that was capable of repelling or killing off some bacteria. That was the invention of penicillin, which was phenomenal. Before then, you could cut yourself shaving, get an infection, and die from it. which today nobody thinks, oh gosh, that's right. I mean, it really feels like an impossibility to you today, right? Well, we may be getting back there because bacteria are very creative and they're capable of becoming resistant to an antibiotic.
Yeah, so we're getting these super bacterias now in the hospitals that nothing seems to kill.
Well, the existing antibiotics are no longer effective. The bacteria have evolved in such a way that they actually don't care, right? Like for example, if you eat me certain type of food, previously it killed me, but now it actually makes me stronger.
Right. So then what about the viruses? They're a different kettle of fish.
Right. So first of all, there's a bit of controversy around viruses. There are people who say that a virus is really an exosome, and it's something that comes from within a human cell, or it doesn't have to be a human, any mammal, actually even bird. So it comes out of a cell, and it's something that the cell expels, throws out. So that's the concept of exosome. Exo as in pushed out. Now, a virus is something that behaves the same way, but we say that it actually has an intention of its own. But it's kind of weird because what we know about a virus, by the definition from the mainstream, is that virus has to borrow the reproductive mechanism of a cell in order to reproduce. So there's this thing called virus, which is a little bit of DNA, but it doesn't have any reproductive capacity. And it gets put into a host. And in the host, it multiplies, and then it gets expelled and sent out. So there's this challenge to know whether it's something that exists on its own or that's something that's created from within a human or a living creature in response to the environment. And this is where we land on the two theories, the germ theory and the terrain theory. And in the germ theory, we hear that the germ attacks a host and does its thing, and the host has no choice. The terrain theory says germs are everywhere, all over in the environment, and they touch everyone everywhere, and it depends on the terrain of the host to either accept it or not accept it, to either succumb to it or be resistant to it. To illustrate, so the epidemic arrives in the school, and 10 out of the 30 children become sick. So we have an epidemic, and the 10 kids got sick. Was it because of the germ? Probably not, because all 30 were exposed, but only 10 got sick. So that probably means that it was the terrain. The 10 weak ones got worse or got sick. And that's what we have experienced in this latest epidemic that we dealt with now 4 years ago, when people who were hospitalized or were seriously ill or dying were those who had comorbidities, who had multiple other problems, high blood pressure, obesity, diabetes, and other serious illnesses. What do you think, Scott? Scott has dogs.
Yeah, I'm looking after 2 dogs here in South Africa. And unfortunately, they've been quiet all day, but now the neighbors' dogs are barking, and they've decided that there's something to bark at. So here we go. I think that you've sort of hit the nail on the head, right? Is why do some people get sick and why do other people not get sick? And I think we'll find out that the majority of the people that get sick are the weak ones. And the first time I ever saw an example of this was in my uncle's wheat field. We were in the prairies of Saskatchewan, and it was a beautiful sunny day. There was these 3 foot high, wheat just going forever. And we were right at the corner of the section. And I looked down and there was all this beautiful wheat, but right at my feet was a clump that was hurt. It was crumpled up. It was not in good shape. And it was full of bugs. There were tons of bugs on this thing doing whatever they were doing. And 3 inches away were perfectly good shafts of wheat that were being ignored. And I thought, so I wonder if this is an analogy for, us, like when we're weak, when we haven't got good, like you said, terrain, we weren't strong, then all these things come in and take advantage of us.
Scott, this has so many other metaphors, right? Like lions are the custodians of the gazelles, of gazelles, antelopes, and whatever. And they are lazy beasts, and they will just scare them a bit to see which one will run away. And the slow one gets eaten. And the slow one is slow either because it's weak, or it has a broken leg, or some other reason why it's not capable of running off with the strong ones, right?
And I would add to that the other third type that is slow are the young.
Yes.
And so they're
easy taken.
Well, I was going to say when the young are threatened, the herd turns, right?
Yes.
Like I've seen lots of videos of, giraffes protecting their young and other, what was it? Wild beast.
Yeah, the wild beast and the buffalo will definitely turn on a lion.
Right. A little impala probably won't, but a lot of times it's, they'll protect the young as much as they can. In fact, I saw one video of a young impala crossing a river, and you could see that there was this crocodile going straight for the young one. And the mom jumped in the river and swam and intercepted the crocodile, sort of sacrificed herself so that the young one could cross. So it was kind of an interesting.
Did the mother get eaten?
The mother got eaten, yeah.
Oh, my Lord. Okay.
Yeah, I'm going to protect
we would put hand in the fire for our children, won't we?
That's right. Yeah. So,
yeah.
So getting back to the viruses and the bacteria, one of the things another analogy I've thought about when it came to viruses is, let's say you were walking around a city, you turn around a block and you see that there was a fire. There's a little bit of smoke, everything's black, and there's all these guys running around in red coats. And you think, well, that's kind of interesting. I wonder what's going on. And then, the next day you go around a different corner. There's a fire, obviously was a fire, and these guys are running around again. And after a while you think, these guys are arsonists. They keep putting these fires up, right? Putting these fires up, lighting these fires. And you don't realize that they're the ones that are putting out the fires. And so I sometimes wonder if when we see the viruses, that's not our body creating things to clean up the mess from the illness, as opposed to actually being the cause of the illness.
Yeah, right on.
So, who knows, right?
Yeah, who knows? And so the other point I wanted to make was the one about parasites, pests, parasites, and other horrible things. They also like to visit weak organisms. What they do is they infect wherever the terrain is less strong. Of course, we humans are always suffering with something. Either it's malnutrition or tiredness or overwork or whatever. However we weaken ourselves and we come across parasites, they will set up house in our bodies. And but that's not the topic for today. Today we're talking about viral and bacterial infection. Maybe we should have added to it fungal. But
I was just going to say, commercial for next week. We are going to be talking about parasites next week.
All right.
So we'll get into it in a little more detail.
Oh, there's George. Hello, George. And he mentioned biofilms.
Yes.
And biofilms are really well worth noting, because biofilm is sort of like the Roman soldier phalanx where they would create essentially a human tank. They had shields, and they would put guys with shields on the outside, on the front side, side, back side, and the guys in the middle were holding their shields over their heads. And they were just marching with the shields all around them. They were sort of like a marching turtle. And they were impervious to the arrows that were being shot at them from other sides. Why do I bring that up? Biofilm. Bacteria like to create an environment in which they have certain types on the outside, the hostile interface, and they protect the weaker ones closer to where they want to eat, whatever they want to eat. So these biofilms are essentially very resistant to attack. And especially this antibiotic story that we started with, the biofilms are antibiotic resistant. They put the resistant guys on the outside, and the inner terrain where they're eating whatever they want to be eating are protected from the hostile environment. Which I wanted to mention and that's this. There are the unfriendly bacteria and friendly bacteria.
Right.
And the friendly ones is the ones we want more of, and they all live within us and upon us, right? Like I have bacteria on my forehead, inside my nose, inside my mouth, the entire digestive tract, stomach, small intestine, large intestine. And there are different terrains throughout there, right? The pH in my mouth is mostly alkaline. pH in my stomach is very acidic. In the small intestine, it's alkaline again. And in the colon, it's acidic again. There are these changes. And different microbes live in different terrains. The scary part is this. We put chlorine in water to kill off bacteria. It kills off everything, which is a good thing. You don't want to be drinking water that has pathogenic bacteria in it. The problem is that if you drink tap water, you're taking chlorine with it, and it's going to wipe out everything within. So you're essentially taking an antibiotic in the form of chlorine as you're drinking tap water. The other common source of this is another antibiotic known as glyphosate. Some people pronounce it glyphosate. Anyway, it's part of Roundup, and it was originally patented as an antibiotic. And the way this thing works, it kills the bacteria that live at the root of the plant, thereby depriving the plant of its nutrients. No bugs, no minerals being dissolved from the rocks, therefore nothing available for the roots of the plant, and it dies. And interestingly enough, if I were a plant, my roots would be the villi that are in my intestine, because I'm providing fresh soil towards the root every time I eat. So what's that telling me? If I put an antibiotic in my gut, I will cause my villi to be deprived of the nutrition. And that's a scary bit, because a lot of chronic degenerative diseases are caused by problems in the gut, leaky gut.
So every time somebody has an antibiotic, or they're drinking water that's been chlorinated, and half the time you can smell it, or most of the time you can smell it, they should be taking some prebiotics and postbiotics and all that good bacteria.
Some way to fix the terrain, right? Like the gut is a garden. Think of it like that. It needs fertilization, and it needs seeds. The bacteria are the seeds. The fertilization is what we call prebiotic, stuff that they eat. Bacteria like to eat things that are medium-sized fibers. like oligosaccharides type of fibers. We find them in chicory and inulin of dahlia and aloe. Yeah, aloe vera has that. Agave inulin is famously good.
What about yogurts? Kefir.
Okay, right. So those would be the seeds, right? I was talking about the fertilizers, now the seed. So
Right.
you need a variety of microbes. You should have the yogurt creatures and the sauerkraut creatures and the kombucha creatures and the kefir creatures. They all belong. I think the greater the variety, the stronger the immune system.
Right, which makes sense, right? Because you want to have, it's like we were talking the other week, we only eat like 5 different foods compared to all of the different types of foods that our ancestors used to eat, right?
I saw a story, somebody was following an orangutan through the forest to see what he was eating. And he said, this guy is like a university level botanist. He ate 400 different species. Like, contemplate. I eat tomato, cucumber, pepper. I don't know. I think I might run out of vegetables I eat by the time I run out of fingers.
Yeah, me too, for sure. Cool. So, Martin, Life Enthusiast has an excellent product that is ideal for people whose digestive system may not have all the things that it should have. And I think we should talk about it.
Yes, we should. We've had
Strataflora.
Yeah, it is called Strataflora. And we've had it since 1994. We've had a lot of success with it over the years. And it's built on the concept of addressing everything. They call it from tongue to tail. Meaning this: there are enzymes in it that help you digest food. There are enzymes and minerals in it that kill off parasites. There are oligosaccharides that feed the bacteria. There are the bacteria itself. We actually put 77 different species of bacteria in it. There are 2 schools of thought about the bacteria. Some doctors say, don't put everything in, target the stuff that you need. Like they will tell you, for example, if you have high level of histamine, maybe you should take the rhamnosus as the species, and you need just the one, it'll take care of it. Or if you have depression, take this one, I forget the name of it, but that's the one that's really good for dealing with that. We've taken a different approach. We've taken the approach saying the bacteria that are needed will multiply. Like it's something like 1,000 to 1 in 1 hour. Like the ability to multiply is just phenomenal. So we put in 77 different species of these seeds, from sauerkraut and kombucha and soil-based organisms and the lacto and bifido and all of that stuff that you will hear about. That, I don't know, I have so many stories. You know, people take it either with meals if their bowel movement is too fast, or take it after dinner if their bowel movement is too slow. Either way, it seems to correct the situation.
So how would someone, like if someone was describing themselves to you, what would be like the clues that would let you know they've got leaky gut or they've got problems with their digestion? Or would it, before you answer that question, I guess the bigger question is, like, do 95% of the population in North America and Europe have problems with their guts?
Well, some people have occasional problems. Like you eat something that's infected with E. coli, and now you have a street fight in the gut, right? The famous travel to tropical countries, we have been calling it the Montezuma's revenge.
Right.
You go there, you eat some salad that was washed with local water that's just not treated, and there you are, diarrhea galore.
You reminded me of a friend of mine that was in Kenya, and he was saying, and a white fellow, he was visiting, and he was looking at some water somewhere, and he said, well, can I drink that water? And they said, no, we can, but you can't.
That's it. Because I'll do a sidebar story. We have this in Strataflora, and this thing is called Bacillus subtilis. And that thing was, well, the story goes like this. German soldiers during World War II were fighting in Africa, and they were suffering greatly with dysentery. And they saw that natives, when suffering with dysentery, would go follow a camel and scoop some camel poop the moment it hit the ground, just took some of it and ate it straight. And that was the cure for dysentery. And of course, the Germans, they didn't see it as simple as that. So they took camel poop to a laboratory and discovered that there was this one particular microbe in it called Bacillus subtilis that kills hostile microbes that are terrible to us. So if you eat Bacillus subtilis, you will be protected against the invading hostile bacteria, like dysentery causing bacteria. So this thing is available by prescription in Germany to this day. We have it available in Strataflora and one other product that is called Antibiotics. So if Strataflora doesn't travel easily to tropical countries because it's a powder, but the Antibiotics comes in capsules and you can easily take it with you traveling. So if you should run into this event, you take 6 or 8 capsules of this Antibiotics. There is a bit of a street fight in your gut, and you wake up the next day fine again. What else to tell you? Scott is busy with something. I don't know what that is. Well, let's see. Strataflora. I remember. Go ahead.
I can tell you, Martin, that I'm house sitting. It's kind of my first couple of days here. I'm not used to it, and there's alarms. So when it got dark, I set out the alarm for outside, and then I am sitting like outside, and there's 2 dogs, and they heard something, and they took off, and they set off the outside alarm. So I ran to turn it off. So otherwise, when I'm talking, you'd be hearing woo woo.
Okay.
So I wish I could think of some quick way to tie that into bacteria, but
well, I mean, you've done enough tropical travels, and you have had Antibiotics with you for the longest time.
I've actually had very little problems with my stomach and with my digestion. There's been the odd time,
yeah,
and I found the best thing to do is just throw up, and then it's
that's a good one.
It's a good one. But the Strataflora has really helped with all of that.
Yeah. Plus, of course, you have been on Iridessa, and Iridessa has Strataflora in it. About 10% of the total of Iridessa is actually Strataflora itself.
Good. I was wondering about that, actually. Every time you talk about a product, I think, well, should I get that one instead of this one?
All right. Well, it's time for me to go join the other side.
That's right. So next week, we're going to be talking about parasites, everybody. Thank you for joining us. And let me just bring, before we go, Martin is a health coach. If we'll put this link in the comments, and he'll give you a free 15-minute consultation. Talk to him about whatever problems you think you have, and he'll be able to set you off in the right direction. Yeah. So Martin, thank you for joining, taking time out of your busy day. And
happy to do it. Thank you, George, for being here.
And
your comments are encouraging. That's helpful.
I have giant bugs landing on me right now. Tropics, I'm not used to this. But yeah, head over to Life Enthusiast and find out about being a life coach, and head over to t.me.lifeandco, and we'll see you soon. Jasmine, thank you for joining us. George, thanks for the exclamations. We'll see you next time, everybody. Bye for now.